Hi friends, in this video we are going to learn the queue data structure. In real life, a queue is very familiar to all of us. When we go to a bank, we need to stand in a queue and the person who is first in the line will be served first. This is exactly what is happening with the queue data structure, and we have a FIFO first in first out functionality here. So the person or the element who came first will be served first and will be gone out of the queue. So let us see the implementation of a queue. First, we declare an array of size 3 and this array will be our queue and it is initially empty. And we need two variables front and rear to represent the two ends of the queue. And since the queue is empty, both rear and front are same now. So both are initialized to 0. First, let us see how to insert an element to the queue, and this operation is called enqueue. So we have function enqueue here for insertion into the queue, and we pass the value to be inserted into the function which will be stored in variable val. Now we are going to insert element 10 into the queue, so val equal to 10, and we call the function enqueue by passing 10. And in the function, first we check if rear equal to size, which means the queue is full. But here it is not. Since we have rear equal to 0 and size equal to 3, the condition fails and we go to the else part. And we add value 10 at rear and increment rear, so rear will be moved one position right and becomes 1. Now let us insert another element 20 into the queue. So we call the function enqueue with val equal to 20. And first we check if queue is full, but it is not since rear equal to 1 and size equal to 3. So we go to the else part and 20 is added at rear and increment rear. So rear becomes 2 now. Now let us insert 30 into the queue. So call the function check if rear equal to size, which is not. So go to the else part and add 30 at the rear and increment rear. So rear equal to 3 now. Now let us try to insert another element 40. So we call the function enqueue again, and first we check if rear equal to size, and the condition is true here since queue is full, so insertion is not possible, so we exit the function. So that was insertion into the queue, and we always insert an element at the rear end of the queue. Now let us see how to delete from a queue, and the deletion operation in a queue is called a dequeue operation, and we always delete an element from the front end of the queue. So we have function dequeue to perform deletion, and in the function first we check if front equal to rear, which simply means the queue is empty and deletion won't be possible. But here front equal to 0 and rear equal to 3, so the condition fails and we go to the else part and we print the value which we are going to delete, which will always be at the front end of the queue, and increment front, which makes front equal to 1 and 10 will be deleted from the queue. So the element which came first into the queue is deleted first. That is the functionality of the queue. Now let us perform another deletion. So we call the dequeue function again and we check if rear equal to front, but front equal to 1 and rear equal to 3 here. So the condition fails and we go to the else part and print the value at front, which is 20, and increment front, which will make 20 no more a part of the queue. Again let us call dequeue and we check if queue is empty but front equal to 2 and rear equal to 3. So the condition fails and we go to else part. And there we print 30, which is to be deleted, and we increment front, which makes front equal to 3. And 30 is now deleted from the queue. Now let us try to perform deletion again. So we call the function dequeue. And when we check if front equal to rear, it is true since front equal to 3 and rear equal to 3. So deletion is not possible since queue is empty and we exit off the function. Now let us understand this more using Angry Birds. So we can add birds one after the other at the same end, and from the other end we can send the birds out. So adding birds at one end and removing them at the other end, and who came first is gone out first. So it's a perfect first in first out data structure queue.